Right, picture this. Sunlight collected in space beamed down to Earth. No wires, no weather worries, just pure, clean energy. Sounds a bit sci-fi, doesn't it? But here's the thing, Japan's actually done it. For the first time ever, they've managed to zap solar power from orbit to a ground station using microwaves. Let's break it down. In space, there's endless sunshine, no clouds, no night. Japanese engineers launched satellites kitted out with super-efficient solar panels. These panels soak up sunlight 24/7, far more than we could ever grab down here on the ground. Now instead of storing it in batteries or sending it down a cable, they convert that energy into microwaves and beam it straight to Earth. It's like Wi-Fi, but for electricity. The implications? Massive. Unlike solar farms back home, orbiting panels never lose daylight. Imagine always-on renewable energy, delivered anywhere, no matter the weather, no matter the time. Think remote villages, disaster recovery, even cities that never sleep, all powered by sunlight from space. Now, I know what you're thinking. Microwaves? Sounds a bit dodgy, right? Well, the energy beams are controlled and super focused. No fried pigeons, I promise. The real challenge is scaling up. This demo was small, but it's proof the tech works. Next, bigger satellites, stronger beams, and power stations floating high above us, raining down green energy day and night. If Japan can pull this off on a global scale, it'll change everything. Clean energy, less pollution, energy equality across the world. From science fiction to science fact, the future of power might just be above our heads. Cheers for watching and stay curious. So, what stands between this dazzling vision and reality? Well, quite a bit actually. For starters, there's the cost. Building, launching, and maintaining solar satellites isn't exactly cheap. Then there's the technical side, making sure the microwave beams are safe, stable, and efficient over long distances. Engineers are working round the clock to fine-tune these systems, but it's a marathon, not a sprint. There's also the question of international cooperation. After all, space is a shared domain. Who controls the satellites? How do we make sure the energy is distributed fairly? These are big questions that need global answers. But with every hurdle comes opportunity. As technology advances, costs will drop and systems will get smarter. Japan's breakthrough is just the beginning. Other countries are already watching closely, eager to join the race for space-based solar. The potential? Unlimited, quite literally. So, while we're not quite plugging our kettles into the sky just yet, the groundwork is being laid. The dream of clean, constant energy beamed from orbit is edging closer to reality with every passing year. Stay tuned. The story of space solar power is only just beginning. As we look ahead, the possibilities for space-based solar power are truly staggering. Imagine a world where electricity can be delivered to the remotest villages, disaster zones, or even entire countries, all from satellites silently orbiting far above. Researchers are already exploring next-generation materials and innovative launch techniques, aiming to make solar satellites more efficient and affordable than ever before. International partnerships are beginning to form, laying the groundwork for a global energy network that transcends borders. The path forward is still under construction, but each new breakthrough brings us closer to a future where clean, limitless power from space could transform the way we live on Earth. The journey is far from over, and the next chapter promises even more extraordinary developments. As we stand on the threshold of this new frontier, one thing is clear. Space-based solar power could redefine our relationship with energy forever. The journey from concept to reality is filled with challenges, but the rewards are equally profound. By harnessing the limitless energy of the sun from space, humanity has the chance to create a brighter, more sustainable future for generations to come. Stay tuned as the story of space solar power continues to unfold, lighting the way to a cleaner, greener world. Thank you for watching. If you'd like to dive deeper into the science and technology behind space-based solar power, explore the links in the description below. Don't forget to subscribe for more fascinating stories at the cutting edge of innovation. Until next time, stay curious. As space-based solar power moves from theory to reality, its influence promises to extend far beyond technology alone. Imagine a world where nations no longer depend on fossil fuels or limited terrestrial resources, but instead share access to boundless, clean energy from orbit. This revolutionary shift could redefine energy security, reducing tensions over scarce resources and potentially easing geopolitical rivalries. Countries currently reliant on energy imports might find new independence, while traditional energy exporters could face unprecedented challenges and opportunities to adapt. But perhaps most exciting is the spirit of collaboration this technology could inspire. International partnerships will be essential, from funding vast orbital infrastructure to establishing fair global energy distribution. Space-based solar power could become a driving force for unity, as nations work together to illuminate the world, literally and figuratively. The dawn of this new energy era may not just change how we power our planet, but how we work together as a global community, ushering in a future where cooperation, not competition, lights the way. As we look to the next decade, the evolution of space solar power hinges on a wave of groundbreaking technological advancements. At the heart of this revolution lies a new generation of satellites, sleeker, lighter, and far more efficient than anything orbiting Earth today. Engineers are pushing the boundaries of lightweight materials like graphene composites to construct massive solar arrays that can unfold in the vacuum of space, capturing sunlight with unprecedented precision. But collecting solar energy is only the beginning. The real challenge lies in transmitting this power safely and efficiently back to Earth. Emerging technologies in microwave and laser energy transmission are being refined, promising to beam vast amounts of clean energy across thousands of kilometers without significant loss. Researchers are also developing advanced rectennas, specialized ground receivers that convert transmitted energy into electricity with remarkable efficiency. Artificial intelligence and autonomous robotics are set to play a pivotal role as well, managing satellite fleets and performing maintenance in the harsh environment of space. These innovations will not only reduce costs but also ensure the reliability of an orbital power grid. In laboratories and clean rooms around the world, the next decade will see rapid prototyping, ambitious test flights, and the first full-scale demonstrations of these technologies. Each breakthrough brings us closer to a world where space solar power is not just a visionary concept, but a practical, everyday reality, lighting up cities, empowering industries, and transforming the way we think about energy forever.